Um, well, we can either call it or we can see if there's anything worth discussing. Do we talk about the testing for the multi-data center area stuff? Anything to talk about there, or do we know what the next step is?
I mean, I'm just going to put up some simple monitor stuff and then start scripting the tests for it with IP tables. I think is my plan. Um, if we want to talk about
Sounds good.
that, what I don't have a good plan on is how to actually, or is like what kind of memory to apply
Kind of memory.
to the monitors for failures, or not failures, but like
I mean,
misses.
like a strategy for trying to map failures onto some
planning.
choke point in the crush map.
No, way before that.
Just for the election.
Just for the election itself. I mean, it turns out that it's like we actually have to build all of it. We don't. When there's a failure, we just hit a timeout. We don't have any idea which like
Yeah, it just reset.
So
my thinking,
I'm building in those interfaces, but I'm trying to decide if the right thing to like, do we want to try and like age them out with some exponential thing, or just like have a linear count of the last n failures are the faults of these monitors?
well, I wonder if we could do something really simple because I don't totally remember here, but I think what happens when they reset, they don't go straight to an election, they do the probe.
Yeah, they do probing and bootstrapping.
And so before the election, there's like an early round where everybody, possibly at least, has done like a round trip ping to all the other monitors. And
Yes.
so in their election messages, they can just say, this is a set of monitors that I know I can connect to as of the last few seconds. So when I think in the election code, then when somebody's gonna, when they either defer or declare victory or whatever, they cannot defer to somebody who has like a smaller quorum than a set of connected peers than they do.
Yeah,
or something like that. And so they would just elect.
The issue is that if we have, is that there's a good chance that there's a network problem that's intermittent rather than constant.
Mm-hmm.
And so we don't want to just like swap back and forth because then like, like maybe we just keep running elections because one of the peons like has an issue with the monitor with the leader that results in 1 out of 100 messages going wrong within the probe's work. So I think we want to remember and say, okay, like
I am more reliably.
If a peon times out the monitor, then it can say, I'm blaming the leader because he did not renew my lease quickly enough. Or the leader can say, hey, I didn't accept or collect back quickly enough from this set of peons, and incorporate that into a deferral strategy.
Yeah, that makes sense.
I think it's important to at least go that far.
Yeah.
But I don't know.
So maybe the first pass is just to make like the basic election code say that like I am participating in this election with this set of people that I know I can talk to, and I'm like either I'm going to try to win or I'm going to defer or whatever it is, but I'm going to participate, and start with that. And then step 2 would be whenever we are kicked out, or we find that we can't connect to another monitor, then we add some like penalty, and then each monitor could like have some sort of variation of exponential backover or whatever, where it like declines to participate if it's having trouble connecting, then it will either exclude one of the other monitors for some period of time or something like that.
Yeah.
I guess what I'm saying is I'm hopeful that if we could probably do the simple thing and then layer in the like the back off into the same algorithm, I guess.
Sort of a 1 or a 0 for the first pass, and then decay it down to something between 1 and 0 based on how frequently you've had trouble with them. I'm wondering whether there's an interesting matrix property that shows up if you represent the sort of suspicion values.
Yeah.
Mostly because I'm wondering what happens if the monitors have different opinions about who they should be deferring to. So it'd be nice if they had this property where depending on what partial information they had, they tended to prefer the same peer if the same peer has connections to all of them. That would be a nice stability property.
Yeah.
Yeah,
I'd have to think about that though.
I think I'm going to want it to be deterministic based on widely shared data. Like they do the all-to-all probing before the actual election process starts. So I think they just like. So I think that means that they can get the data from everyone they talk to in the probing and share it with everyone they talk to during an election for the processing. So they can work on the same data set, or at least it'll be a common data set. But
the interesting thing about the monitors is they don't actually have to be fully connected. All the monitor communication is between the peons and the leader.
yes, that is true.
Peons don't. So we could actually have something that isn't like, it isn't really an n squared problem. It's just that when you're deciding who to defer or not defer, monitor A can say I can talk to these 3 peers. Monitor B says I can only talk to 2, and monitor 1 says I can talk to 3. But you just don't defer to somebody who can talk to fewer people than you do.
Yeah.
And that would, so they could form a quorum that isn't actually fully connected, and it would actually function just fine.
Yeah, that's plausible. It's also not necessarily a thing that we want to do though, because the most likely outcome of that is that all the monitors is that if in our like 2 data centers and a third tiebreaker mon scenario, then the tiebreaker monitor becomes the leader, and they probably have the highest latency out of all of them, which is undesirable.
Yeah, but it would
that
form
matter?
a quorum when you otherwise wouldn't, right? And this is sort of independent of whatever happens after that. Like they form a quorum, but they also share information about connectivity, and they realize that there's a huge discontinuity between the 2 data centers that they can't talk to each other, and so maybe it like doesn't allow something else to happen or whatever. Like all that stuff is sort of the next step. But it seems like all things being equal, it might be better to have a quorum than not have a quorum.
Well, it's better to have a quorum than not, but it's not necessarily better to have not fully connected monitors in the quorum. For instance, if we let the monitors form a quorum, then they let clients connect, which
I think you want to handle that explicitly, Greg. I think you want to handle that explicitly. I think it's always better to have more copies of the monitor state than fewer. So if we want to disallow clients from the losing partition, I think we should do that, but we should do it on purpose, not by just making the monitor not connected.
And even if you're talking to the monitor,
and I'm not saying that's necessarily a bad place to end up, but every time I've talked about this so far, you're like, okay, let's do the simplest thing we can that works first, and that is not that. That's the opposite of that. That's depending on all the other stuff to get built first. So we want to.
Well, no, because then the monitors work properly even when there's a partition. That's the state 0, right?
Yeah,
no, I think state 0 is that we just pick a side, and that side gets to function, and that's easiest if its monitors aren't participating.
But it's kind of irrelevant what monitors are. Like, say you have data center A, B, and the cloud is C. And so you can either form like an A and B can talk to each other, but they can both talk to C. Then you have either a quorum of AC or BC.
Yeah.
But like whether or not say that you have that split and the people in B aren't allowed to connect to the B monitor, they have to talk to the C monitor. I don't know if that's like strictly any better or worse than what you would have if you actually had, like, you still have to solve all the other problems.
Well, if they can reach the C monitor, then they can route to the A monitor and to the A networks too, so they're actually still functioning, right?
No, maybe not. Right now, there's a connectivity break between.
Yeah. Okay. Yeah.
Like I think we were oversimplifying the problem before. I think you're right, but given that, I have this feeling that we're going to have to address those issues anyway.
Yeah, that's what I was pointing out with the peering thing. I don't think you can solve that
Yeah.
purely by making the monitors work, so you may as well do the most robust thing for the monitors and then solve the other stuff.
Yeah. Well, I think the nice thing is that just picking the monitor that can talk to the most peons is actually an easier change to the election logic than picking the largest fully connected subgraph or whatever
Mm-hmm.
you want to call it. I think it's actually simpler to implement
That'll be true.
Mm.
because every monitor basically has a score. That's how many other monitors can you talk to, and you want to pick the highest one that has the lowest rank or whatever the whatever the criteria is.
It's the same monitor won't report to two different monitors that with different values for that connectivity, except maybe monotonically increasing. Everyone should agree.
Yeah,
Or
and it only
everyone can
matters
talk to them
really
anyway.
it only matters what the leader can talk to. How many
No,
people
I mean,
the
so
leader can talk to.
everyone will end up deciding that the same one should be leader.
Yeah.
So
I
it
mean,
should
they
be
could
stable.
advertise it. They can advertise it
Exactly.
in their election.
Yeah, that's what I'm saying.
Right.
If everyone has that same information, it should be stable. It shouldn't oscillate.
Yeah. Yeah.
Hmm. I'm actually not sure I'm comfortable with that though. Well, I mean, so yes, it's nice to have more copies of the monitor data, but if only like if we get into one of these connection breaks, I'd rather have a local monitor in one of the databases be the leader, not the cloud. It'll have faster commit latencies. It'll have faster access latencies for the clients,
Mhm.
and I think it'll be easier to communicate that the state of the system to administrators that way. Um, Also, that's a lot easier to generalize to, okay, we think that to eventually generalize to, okay, we think monitor C is, or not, whatever, monitor database or data center 1.b monitor is like unreliable. So we're going to exclude just that one because it's been breaking leases or something.
Yeah.
It just seems
I mean,
like an orthogonal feature as well.
I think, yeah.
Well, but I think in this scenario, it's not going to be orthogonal because like we're worried about network connectivity issues, and it might be that they just go down, but I think like losing a big chunk and having a way oversubscribed link is a lot more likely. And at that
Just
point,
because of the monitor?
well, no, I mean it'll
That
probably
doesn't
have
sound
the
right.
whole data center, but like the monitor messages are likely to be able to get through at extremely high latencies that will often break lease timeouts.
Well, I mean, you
But
can
often enough to do an
you can
election.
penalize them based on latency, right? Like you can separately decide you don't want to include anyone in a quorum who's more than X slow from the leader. And since we define the leader to be the most connected peer, that seems like the fairest way to do it.
Well, but at that point, then the leader is actually likely to be a very suboptimal monitor for the people that we're actually participating, right?
Maybe. I'm not sure
Yeah.
how much different it really makes.
I think
the
if
commit
the
latency is still two-phase across the WAN.
I mean, the only win is on
There'll be
reads,
one
right?
more hop, but yeah. It'll be a little bit slower, but not that much slower.
It isn't
But
the whole point. Oops, sorry.
I think you could, if you really didn't want the remote monitor to be the leader, you could also just you could devise a simple scoring function. So like we were saying that the number of monitors that you can connect to is your score during the election, and you pick the highest one. But you could define a function. Like you could have monitors that are like twice as preferable as the other ones, and so you just like scale them up or down or whatever it is. And each monitor could just like say, my score is 7, mine's 9, and it's an all-to-all share, whatever during the election, and so you just defer to the one that claims a higher score than they do. And so you could, if you wanted to, you could just like pretty easily say you prefer not. And depending on how you set the threshold, you could make it so that you prefer a quorum of 2 with a leader in a local data center versus a quorum of 3 with the cloud one or whatever it is. Or you could scale them based on like how flaky their links are or something like that, or how much load they have on their server. I don't know. Like you could do whatever you want there.
And actually, no,
I'm
it
not.
does make a big difference. If we've got a like tiebreaker with 700 milliseconds of latency, then everything that originates in the running data center to change that is 2 round trips, so 2.8 seconds instead of 1 round trip
Yeah.
to do a commit. And that's pretty significant.
I don't think we're going to see 700. I know that's the number that we
And
just
that's
like
the
pulled
number
out
I
of
was
the hat.
given. I maybe not, but
I think we sort of made it up as like a big number.
I think
But
we did too. But I mean, like,
and what's the latency from here to Singapore, like going around the world? It's like
120,
more
right?
than that.
20 milliseconds. So you'd have to
uh,
have like around the world and a saturated link or something like that to be.
I really.
I could be wrong.
I mean, maybe if you have like your own
50 across
cable
the
or
country.
something. I think when I'm in Europe, then my ping to like my box here is like 700 milliseconds from Los Angeles to Europe. So
If I ping Singapore, I get 93 milliseconds.
I mean, you can play StarCraft from the US to South Korea with only about 100 milliseconds of ping.
all right.
Well, I don't know that we need to over-engineer it initially. I think we can do something pretty simple. I think the first step though is just to add the technology tasks to enable disable links blockages or whatever between nodes, right? So if you have a technology test with 3 nodes, each representing the data center, a
Yeah.
command that'll basically let you shut down connections between B and C or whatever it is. Because that we're gonna need that for like everything. And then we can just reproduce it. We can like show what happens. We can yeah, one thing though actually that's going to be slightly weird is that the way that the monitors work right now. Actually, no, we fixed that. So what used to happen is that there was a defined sort order in the monitor map. So if you had a set of monitors, they would always sort by their IP address. And that was effectively random based on like what the technology machine allocation got you. And so, which machines got Mon A and B and C or whatever would be sort of affected by what IP address was on that machine. But that's not the case anymore. You can adjust the rank order in the mon map explicitly. You can put it however you want I think it was Nautilus, maybe it was Mimic.
Really, that's
So we'll
actually
want,
accessible now.
what's that? I think this can be
I
set.
couldn't
Yeah.
remember if that feature was accessible for ordering them. I thought it was still because you were talking about it and it was like only via DNS or something. Although I think it was getting
Oh, that
fixed.
was a second. That was a follow-on thing. That was about the monitors searching. No, it's in there's a change on the mon map. So if you do mon dump, what's it mon dash h? Can't remember what the command is. You can do set rank, ceph mon set rank name, and you pick what position it's in, and so you can explicitly put them in whatever order you want. So we'll probably want to make in the test, if we have A, B, C, whatever, we'll probably want to explicitly like specify the rank and probably programmatically vary it. Because sometimes we want Mon A to be in data center A and Mon B to be in the cloud and Mon C to be in data center B, but sometimes you want them the other way around, whatever. Or sometimes you want them to be listed first or second. Probably, I don't know, maybe. But we'll have to pay attention to that in the testing. I mean, it would be interesting just to set up, add the technology tasks and just set up a simple 3-mon cluster and block communication between like 2 of the 3 machines.
Yeah.
And just have the leader mon be on in different, have them assigned in whatever the 6 different combination or 3 combination orders that you can have, and just see which ones work and which ones don't. Because I suspect in some of the cases it'll just work because the leader happens to be the one that can talk to all of them, like the lowest rank one, but in the other two it won't. They could have like a facet that is the mon to blockage assignment, or the other way around, where you block AB or you block BC or you block AC, and then just see what effect it has. To establish the baseline, and then we can start experimenting with ways to address it.
I like the sound of anything that lets us validate guesses.
Yeah. Yeah. We can start with just like blocking all traffic, and we could also have a variation that like adds the delay thing that you do, right? The queuing delay.
Yeah, that's all still just in.
That's all going to be super annoying. Harder to fix the queuing delay, I think, but or maybe not. I mean, it might be that. So if we went with a strategy where the monitor that has the best connectivity with the most peers wins, then we can just basically fabricate a function where you get 1 point for every mon that you can talk to, but if it's high latency, then it's a little bit less than 1 or whatever. And so we can scale it however we want to do it. And so hopefully we'll pick during the election, hopefully pick the best mon in some sense.
Yeah.
That has the best overall connectivity to as many peons, whatever.
Yeah, it seems like we'd want them each to have a reliability score.
Yeah, it seems like we'd want them each to have a reliability score.
Whoa.
Yeah.
Brad, I think you're echoing.
Brad, I think you're echoing.
And muted.
You can hear the echo, but not him.
That's weird. Maybe I'm echoing, but I don't see how that would have worked. Okay, good. Yeah, it seems like we'd want to have like a reliability score for each monitor and then maybe something and then also points for like each, like a,
yeah,
like their connectivity graph multiplied by their latency per node or something. Well, not but like some scalar for that, and also a reliability score for it, so that if we have a leader that keeps on failing to extend leases, then we bounce it around to someone else.
Right. Yep. And so if one monitor is misbehaved, that can like knock down its score, and it can slowly creep back up and all that, whatever we can. But
I think that's going to be a major concern for us, because like we sort of just bounce around for them within a data center right now, and that works, and people mostly don't notice. But
yeah, we'll say they.
Brad,
it's not working,
and
then fix it. Yeah, but it'd be nice if it could deal with it, I guess. Well, I guess the real question is like a one-dimensional score metric sufficient to like factor all that stuff into that score and have it behave? And I think probably, but at the end of the day, there's some like preference of like which one you want to be the leader. The one-dimensional.
Yeah. So Brad's asking if we need a real monitor for this or not. And yes, we need to store the same data, Brad, because it needs to count as one of the nodes that commits data. Like if we have 5 monitors and it's one of the 5 and it's like doing a tiebreaker, then we need to maintain our more than half Paxos guarantees.
Yep. And if you have a monitor that's like participating in that, it's like promising to remember a to be committed value, but then it doesn't actually store data, then it whatever, Paxos breaks. And
essentially,
it
could be enough to prove that a value needs to be remembered, but not have the value, which would be unhelpful.
Yeah, right. Exactly. Yeah, I don't want to mess with Paxos. I think it's been like 2 years and we Our last Paxos bug, so that's good. Okay.
What are the requirements for the decision about who defers to whom for it to be stable? Is there like a concise way to state that? Because as I understand it now, there's a static preference order, right?
Yeah, it just prefers lower ranked monitors. That's all it is.
So that has the benefit of being widely known and non-arbitrary, in that any two monitors deciding between the two sets of monitors will come to the same decision. What are the consequences of changing that to be based on dynamic information that might be different on different monitors?
I'd have to look at the election code. I mean, the elector is like super simple. If I remember, everybody like broadcasts their participation, and then if they see somebody that's better than them, they send a defer message to them that says, "I defer to you." And if somebody gets enough defers, then they broadcast a victory to everyone else, and that's basically it.
Which I think means that you basically defer to everyone who's got a higher score than you, or in our case, the score is ranked. So like, if you're rank 3, you will defer to ranks 2, 1, and 0, and they all get those messages.
Yeah.
So they actually do need to agree. You won't be able to commit anything successfully that gets lost, but if they disagree, you'll just continuously run elections because, like, rank 3 will say, "No, I was supposed to be leader. I got my things, and something happened, so I'm calling a new election."
Yeah, that's what I'm wondering.
Yeah, so I think we want it to be stable, and the way we'll do that is by calculating based off of the shared data from the probes.
But they'll all have different shared data. That's what we're
I don't even think you have to do that, because during the first round of the election, where everybody just broadcasts like, "I want to participate," you can just say, "I want to participate, and my score is 12." You can just unilaterally declare.
So anyone who considers you to be a valid option compared to someone else would have the same two values. Okay.
I don't think we want to like claim scores for individuals, but I think it's that they will.
Well, it's claiming for yourself, right?
What they see.
Claiming for myself for this round. Saying I'm on.b. I want to participate. My score is 5 right now, because I can talk to this many other monitors, and I've been kicked in the butt this many times, and so I've scaled it back. But as a result, my score is 5.
Is it important that score remain the same for the whole round?
I think it's, yeah, I mean, the round lasts like a few seconds. And if it fails, you do it again, so you'll pick a different score.
I don't think, Sam, that there's going to be an opportunity to adjust them within the round unless we do something really weird.
No, I meant if you get back more responses from other replicas during that time.
That's not a thing that can happen.
Doesn't matter.
They probe to everyone who they think is up or who was in the previous round. When a timeout happens, then the monitor who called the timeout, which will generally mean either the leader or else everyone, because the leader timed out, will do bootstrap or we'll go into bootstrap and we'll probe. And that, I think, triggers all-to-all probing, although I'll need to check that.
Yeah, I think we don't always bootstrap. Sometimes we just call an election. So we don't always.
I just went through this today, and I don't think we do that at all anymore. It's always the full process, which was confusing to me because I thought we just we're going to call start election, and I didn't see it anywhere. Or no, there's some CLI commands that will trigger it, that will have it call an election.
Okay, well that simplifies it then.
But other than that, it's probing, and I think once you get a probe, then you probe everyone else too. Although I'll have to double check that because I actually didn't look at it specifically. But I think that means that every monitor will have attempted to communicate with everyone that it thinks should be participating, and that'll and so by the time we get to sending election messages, we will have a bunch of data, and even if you missed someone, then if there is a path between you, then it'll get shared.
I think also I think you're right that the probe will have the information that we need, but if it doesn't, I don't think we need to worry because the elector is like self-contained process, and it's super simple. We can change it.
Well, no, I
We
mean,
can make it
I
we
think
can make
I
it a
think that
two-phase
probably
election.
going to need to be is going to need to be the authoritative source of data that they use for calculating deferrals in that round is why that matters. Because it's not going to like, especially if we do what we're talking about here, it's not going to be a single score. It's going to be like connectivity and latency and reliability scores.
Well,
Yeah,
I think
but
the
that can come from
proposal is that
anywhere.
each monitor independently like turns all of that stuff into one number.
Yeah, right.
I
And so in the election message, you just say, "This is my score," and wherever you get that score,
well, no, I mean that won't work because a monitor will consider itself reliable in most cases, but it's what the other people think of it that matters. So it's
well,
going to need.
we could just say that that's. I mean, we're not trying to solve Byzantine problems, right? We're
No, we're not
assuming
trying to solve Byzantine problems, but if okay, so
The
if we have,
assumption is that if I believe I can connect to B, then B will also believe they can connect to me because it was a ping and it was a round trip. I think that's the missing assumption, which I
and
think is
in
valid.
and when you ping, if I'm B and I ping C, and C replies, and C thinks that B is an asshole and they keep misbehaving, they can just like say so, and so B can like
well, not if
adjust
they're
the score
only
accordingly.
not if they don't get to spread their information about C by
No, but
broadcasting
C
a data
themselves
set
won't get the
within
response, right?
score.
Or they'll get a response that says, "Yeah, I got
Yeah.
your ping, but don't count me."
Right. Yeah. Or I got your ping, but you keep calling elections, and so rank yourself lower, or whatever it is.
I'm not sure that's simpler, especially since it relies on being able to since you have to reliably transmit a
Well,
message in order to make someone lower their score.
No, because failure to do it gives them a 0, right? They get nothing from you.
Yeah. And it removes the requirement that everybody have the same shared information that is exactly the same. And so they have a shared understanding of what scores are. That's hard. But if everyone, by participating in the collection, says this is my score, then we just have to get enough information to them ahead of time so that they can choose a good score. And since that ahead of time includes round trip pings with everyone, then that should be an opportunity for everyone to tell anybody else any information that they don't already have themselves.
All right, I'm going to need to look at this again then because I don't. Well, first of all, I don't think that's actually any different than just doing a full data sharing. And once you do a full data sharing, you have a common data set to work with, rather than.
Yeah, it might not be, but but
That's
it's
like a lot.
simpler to
That's
it's
a lot
simpler to
simpler
think about.
And it means that the external monitors can say, okay, I see that A and B are not communicating with each other, but are communicating with these other groups. So we think that there's a connection problem there, but which
Well, does
allows
that matter for the monitors?
it might not matter right now, but yes, it's going to matter because that's a clue about the way
But
we
not a
want
very
to.
good one. The monitors
hearing.
have this massive collection of OSDs that can go solve that problem for them, right?
Only kind of. In that
Honestly, if we want to solve that problem, I think we should add a daemon to each OSD and have it report information to the manager or whatever.
well, no, I mean,
I don't think it's important.
only the leader gets failure reports that are actually useful, right? Because everyone else only sees the failure reports from whoever they happen to be.
No, I get it. So I'm saying the right answer is to solve that problem, not to overload the monitor election process. Remember, the monitors are just the monitors. It's just those nodes. That's not every link in the data center. It doesn't tell you if a rack is out or something. That it doesn't have the monitor, for instance.
I think you're trying to oversimplify the useful sources of data. Like monitors are, yes, they are just one node, but they're also a very important node within the system.
Only in the sense that they're used to form a quorum, though.
Well, okay. So either way, the first step is to build the topology hooks to actually do this, and we can build those, and we can build the tests and show that 2 out of 3 combinations fail or whatever it is before we make any changes to the mono election code at all, right? We can do that, and in the meantime, we can map out a specific change to the election sequence, and we can argue about that over the next week or whatever. Come up with whatever we think is simplest.
Yeah.
That
okay.
solves the mon-election piece.
Anyway, I think we've beat that enough. So,
Yeah.
do we have anything else you wanted to talk about, or?
Else? There's like the mon memory target is sort of in progress. I'm gonna do an MDS one at some point. I think Patrick will do that.
I think the MDS one is done, or at least.
Oh, really? In progress. I haven't been following.
I haven't been following it either, but I mean, like, it's got the cache limits, and they have approximations for how much real memory uses based on a cache.
Okay.
So I thought he just had to like plug that in. Maybe not.
Yeah, I think yeah, I think that's the next step.
Oh, and he was also looking at using Mark. Like Mark pulled the tuning out of.
That's the thing I'm thinking about. Yeah.
Is there I didn't know there was anything happening with the monitors though.
Yeah. One of the folks from Bangalore is looking at it. Sridhar, I think is his name. Is that right, Neha? Sridhar.
Yep.
Oh, right. Okay.
What's
the approach we're taking there though?
I mean, it's the same as there are basically two knobs that we can adjust. There's the RocksDB cache size, and there's the OSD map cache size. Those are the two things that we can really vary.
Yeah.
And we're going to use the whole priority cache framework that Mark set up to like prioritize the RocksDB index caches and then balance the OSD map cache and the rest of the RocksDB memory.
That makes sense. I'm just worried about like the incoming entity messages too, but maybe that's not any more of a problem for
They just have a cap, I guess, so we just need to make sure that's not too big.
Yeah. Yeah, I guess it's not really any different than OSD's doing data IO. So yeah, cool.
All right. Oh, Brad, I did have one thing I wanted to check in with you about. I don't know if your mic's working or not, but way back after you did the change to the OMAP approximation, we talked about adjusting it so that it could hopefully trend towards accurate even after a scrub. So for example, when you insert a key, it would add that many bytes to the total. And when you deleted a key, it would subtract its estimate of the average key size. Something like that. It won't be completely accurate because you don't know if you're replacing a key or inserting a new one, but we could guess, I guess, if that makes sense. Talk about. Oh, we didn't think it'd be very accurate. Okay. Yeah. Okay. All right. Yeah, maybe not. Okay. Yeah, I mean, at the end of the day, the problem is that when you insert a key, you don't know if you're replacing a key, you're adding. Like, there's just no way to know unless you read first, and we don't want to do that. All right. Well, I don't have anything else. Yeah, we can talk about it. Yep. Anybody else have anything they want to cover? Follow it. Ready. Good. Have a good night, everyone. Morning.
See y'all later.
Yep.
See ya.